When we are talking about water and its properties, we need to understand first the chemical structure for water. It has got two hydrogens and an oxygen. So one hydrogen is bonded with a single bond to oxygen, and then the same oxygen is having another single bond with another hydrogen. Now, as I said in the previous lesson, let's look at the periodic table generally. That's how it is. So on the periodic table, at one end, which is at the far end here, we've got fluorine. Fluorine is the most electronegative atom on the periodic table, meaning whenever fluorine gets to form a bond with any other atom, as long as it is a covalent bond. Remember, a covalent bond is a bond between nonmetals. So as long as there is a covalent bond between fluorine and any other metal, fluorine is going to pull electrons towards itself. Now remember, a covalent bond doesn't involve losing and gaining, it involves sharing of electrons. So these electrons in this bond are going to be shared, and each bond contains only two electrons. Now, because oxygen is more nearer to fluorine than hydrogen, which is somewhere there, meaning oxygen is more electronegative. Because of this, because of a higher electronegativity, so we define electronegativity as the ability of an element or an atom to pull a pair of shared electrons. So these two electrons which are in this bond are going to be much more closer to the oxygen. So in other words, they're going to be found near the nucleus of oxygen more than being found near hydrogen. Even if it is like that, these electrons are not lost from the hydrogen. It's just that oxygen has put them more to itself. So because of that, electrons are very much near oxygen. There will be a partial negative charge on the oxygen like that. If there's a partial negative charge on the oxygen, there will be a partial positive charge on the hydrogen, and same also this side. So we say that water, the oxygen of water has got two partial negative charges, and because of this is what makes water to be a dipolar molecule. So water is dipolar. You need to know that. That is one important thing about water. It is a dipolar molecule, meaning it has got two poles. It has got a positive and a negative pole. Now, why is it that water is dipolar? It has got a net dipole. What do we mean by net dipole? If you consider the way I've written this, a dipole, as I said last time, we just get to show a line, and that line will be going towards the atom that is more electronegative. So this is positive, this is negative. So we're going to draw a line that goes like this with an arrow, and then we'll put something like that. And also this side we've got negative, positive, so also draw a line like that, and then you put like that. Now, if you can just remember a little knowledge of vectors in physics, when you have got a line like this is a vector because it has got a direction. Of course, there will be also a magnitude. So you can break it into the x component and the y component. So same with this vector, you can see that it is at an angle. It is not straight up and it's not straight forward. So it can be broken down into the y component and the x component. So this vector here is the one I've broken down like this. And also this one, I'm also going to break it. So it's going like this. So it is also going to have a y component and x component. So if you see these two lines are going in the same direction, they are going to cancel each other. But this one and this one, they are going up. So imagine you are pulling something forward and then another person is pulling it forward. So there will be a force that will make it to even move faster. So in this case, water has got a net dipole towards the oxygen like that. This is a net dipole in water. So we say water has got polar bonds. Why are we saying polar bonds? If you look at this bond, the electrons are more closer to oxygen. That's why we say water has got polar bonds. And it is also a polar molecule. Why is it a polar molecule? Because it has got a night dipole. Now I'm going to explain for you. There are some atoms or some molecules which have got polar bonds, but they are not polar themselves. For example, carbon dioxide. Carbon dioxide is like this. It has got two double covalent bonds. Water has got two single covalent bonds. This one has got two double. These are exam questions. Please pay attention to them. Water has got two single covalent bonds. Carbon dioxide has got two double covalent bonds. Now, because still when you consider oxygen and carbon, oxygen is more electronegative than carbon because oxygen is in group 6, carbon is in group 4. Oxygen is more electronegative, so it pulls electrons towards itself. So that means the carbon decided to remain partial positive, decided to remain partial positive also. So if we want to draw a dipole always go towards the more electronegative atom like that, also this side like that. Now because these vectors are not at an angle, you can think of it, you are pulling something and then another one is pushing it. It might not move if you are using the same force. So these two dipoles cancel themselves. That is why carbon dioxide has got polar bonds, but it is not a polar molecule. Meaning overall, this molecule, the poles are going to cancel out. So again, carbon dioxide is linear. It is a linear molecule, as you can see. I've drawn it straight. Water has got a V shape. That is the shape for water. It is V shaped. Or this V shape, we also call it as bent shape. So if they say what is the shape for water, it is a bent shape or a V shape. Carbon dioxide is a linear molecule. So we've talked about the dipolar nature of water. We need to know that. Now, because of this dipolar nature that water has, because of this kind of distribution, why is it that water has got this kind of shape, the V shape we are talking about? That has to do with some electrons which are found on the oxygen. That is why water has got this shape. So we're going to look at that. Let's get to look at it even now. So if you consider just when you are forming a bond, oxygen we say is in group 6. That means oxygen has got 6 electrons in the outermost shell. And then hydrogen has got, we know it has got only 1 electron in the outermost shell. So this one has got 1 electron. This one has also 1 electron. But oxygen has got 6 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, like this. So what happens is this electron and this electron, they are going to come together forming a bond. This electron and this electron also come together, they form a bond. So you have got these two electrons which are not participating in a bond. So those are the ones which are responsible for the shape for water. So now I'm going to put it like this, and then we're going to put it like that. So we say that water has got two lone pairs. Water has got two lone pairs of electrons. There are two pairs. So please, it is not two electrons. It is two lone pairs of electrons. So we are saying it's a pair because there are the two of them. Otherwise, there are the four of them. Okay. So if you want just to say in terms of how many electrons are there, just say there are 4 electrons which have not bonded. Otherwise, if it's a pair, then there are 2 pairs. I'm going to write it again just so that we say clearly. Now, because we know that electrons are negatively charged, these are found in the same orbital. These are also found in the same orbital. Remember, an orbital is just a space around the nucleus where the probability of finding an electron is maximum. So electrons are negatively charged, and you know that when negative things are near each other, they are going to repel. So because of this, these are going to be pushing each other. They are going to be pushing each other, and when these push, and remember this bond also contains electrons, so there also be a repulsion between these electrons in a bond and these electrons. So because of those pushings, because they are repelling each other, that is why you form this angle, and this angle is 104.5. So to know it in water, it is a very important angle. So the bond angle in water is 104.5 degrees between the two hydrogens and the oxygen. So this is about the dipolar nature of water. So because water has got poles, this one is partially positive, also this one is partially positive, this one is negative, of course having two partial negative charges, it can form hydrogen bonds. So this hydrogen can interact with another water molecule. So this portion that is that has a negative charge from another water molecule, these can attract each other. Remember, negative and positive things attract each other. Now, this attraction is not, they are not, it is just an attraction, it's not a bonding. That is why water molecules always tend to attract each other. You can't count water. You can't say one water, two waters. That is because these hydrogen bonds are so many, and because hydrogen bonds are so many, water is held closer together to each other, and they are so strong. Well, water can not only form hydrogen bonds with another water molecule, they can also form hydrogen bonds with other compounds such as ammonia, because ammonia contains hydrogen, nitrogen. Remember we said a bond between hydrogen in one molecule with either nitrogen, fluorine, or oxygen. These are from different molecules. If you are talking of the hydrogen and the oxygen in the same molecule, that is not a hydrogen bond, that is a covalent bond. It should be in different molecules. That is what we call hydrogen bond. And pay attention of those atoms we've talked about: hydrogen with nitrogen, fluorine, or oxygen, not fluorine, no. All right. So apart from ammonia, it can also form, water can also form hydrogen bonds with the carboxylic acid functional group, that is COOH. We can this C bond with oxygen and then OH. So there is this oxygen you can see here. It can also interact with the hydrogen in bonds. So at this point, if you've got a question, please be sure to ask. So we look at the properties for water now. Do you have any question? Okay. So if you consider the way water is like this, and when you talk of ammonia, ammonia is N with three hydrogens, and then this nitrogen has got a lone pair, just like this one has got two lone pairs. So this hydrogen interact with this nitrogen which is here, and this is going to form a hydrogen bond. It's not a connection, it is just an attraction. Yeah, it's just an attraction, just like, sorry for using this example, you can you can have this person who is married but they are attracted to another person, not that they are really connected in marriage, but they're just attracted because of their genders and such things. So that is how also these are, is just an attraction. And you need to know that a hydrogen bond is longer and weaker than a bond. A covalent bond is short, a covalent bond is strong, but a hydrogen bond is long and it is short. And you can also talk about a carboxylic acid. You've got water. Carboxylic function of it is N, sorry, is C double bonded with oxygen, and then there's an H. This oxygen again can interact with this hydrogen, and that is going to form a hydrogen bond. It is from a different molecule. As long as you see a molecule that contains this a oxygen that has got some lone pairs, this oxygen has got lone pairs. So these lone pairs are interacting with the hydrogen. Remember we defined hydrogen bond as an interaction between hydrogen in a dipolar molecule with the lone pairs of another atom in a different molecule. Is it okay at this point? So now let's get to look at the properties for water. What are some of the properties that water has? About is water is an excellent solvent, excellent or universal solvent. That is one property. Now, what do we mean by excellent or universal solvent? Meaning, water can dissolve anything, like almost anything that comes in contact with water, it can dissolve in water. Something in which something else can dissolve. So, water is an excellent solvent. When you talk of ionic compounds dissolve in water. And how do they dissolve in water? They dissolve because of the interaction between those ionic substances and also water molecules. Remember, water is what is a polar molecule. You need to know that something polar dissolves in something polar, and something non-polar dissolves in something non-polar. Something polar cannot dissolve in something that is non-polar. So, for example, I'll talk of sodium chloride. If sodium chloride breaks, you have got sodium, which is a metal. Remember, metals lose when you are forming an ionic bond. They lose electron charge. They are called cations. And then chlorine is a non-metal. When it gains electrons, it becomes charged. That is called an ion or anion. And then this is a cation. So those. Now that's from here. And you know that water has got also positive and negative portions. So what is going to happen when sodium chloride interacts with water is that the sodium, which is positive, I'll put it there, and then the chlorine, which is negative. So the sodium, which is positive, is going to interact with the negative parts of water. That is, the water is going to align itself in this manner, and it is going to surround this sodium. So this is what happens. And then for the chlorine that is negative, the water that is the hydrogen is the one which is going to be much closer to the chlorine. So this is what is going to happen. So the chlorine is surrounded by positive, because positive and negative attract each other. And the reason of this is when this happens, this sodium and this chlorine, they can no longer come together because they've been surrounded. They are being prevented from coming together. When you put sodium chloride, of course, is table salt, the same salt that we use, that's sodium chloride. So when you get salt, you put it in water, you will not be able to see any particle. Why? Because they've been disassociated, they've interacted with the water. So this is what, and anything that you get to put in water that dissolves, this is what happens. They interact with water, they are separated. Hope this is okay. Is it fine? Now, any property that we look at, you need to know it and also the importance. Now, what is the importance of water being a universal solvent? But you need to know that not everything gets to dissolve.
And that is the important things have to dissolve in water. For example, for food, the nutrients to be transported in the human system, they have to be dissolved. And where do they get dissolved? They get dissolved in water. You can talk of just blood itself. Without that liquid part of blood, which is the plasma, how would you survive? You can't, because if blood gets to clot, that is when it comes together, you are going to die. So water is very, very important for survival. And this property, universal solvent, is very, very important because chemical reaction happen in an aqueous environment. So that is the importance for water being a universal solvent. Another property that you need to be aware of is